Hello and welcome to Excel Mathematics TV. This presentation will be about zero and negative exponents. Have you ever encountered numbers with zero or negative exponents? In this lesson, you will learn how to solve zero and negative exponents. Let's start with the zero exponent. So, you know how to simplify a number if its exponent is 1, 2, 3, or more. All we need to do is multiply the base by itself, and the exponent will tell us how many times we should multiply it. But what if the exponent is 0? We can represent zero exponents as x raised to 0 equals 1. Now, what does this mean? It means that any number raised to 0 is equal to 1. And that's pretty easy to remember. Any number you can think of will be equal to 1 if its exponent is 0. Now that we have an idea on how to solve zero exponents, let's apply what we've just learned. Let's simplify the following. First, we have 4 raised to 0. Since the exponent is 0, we will apply the zero exponent rule where x raised to 0 is equal to 1. If that is the case, we can say that 4 raised to 0 is equal to 1. And it's as simple as that. But let's still have another example. Let's try solving the product of 7, m raised to the 8th power, and n raised to the 5th power is raised to 0. Again, we will apply the zero exponent rule. This rule states that any number raised to 0 is 1. No matter how big or small the number is, when it is raised to 0, it is just equal to 1. Therefore, we don't need to think further. We can say that the product of 7, m raised to the 8th power, and n raised to the 5th power raised to 0 is also equal to 1. The rule in solving numbers with zero exponents is easy, and I'm sure that these two examples are more than enough for you to understand the concept. So we'll move on to our next topic. Let's learn how to solve negative exponents. If we're going to put the concept of negative exponents in an equation, it will be x raised to negative n is equal to 1 over x raised to n. Putting it into words, we can say that if a number is raised to a negative exponent, the result will be 1 over that number raised to its reversed exponent. Having said that, we can say that if x is raised to positive n, the answer would be 1 over x raised to negative n. If the explanation left you scratching your head, don't worry, because you'll surely understand after we do some examples. We will write the expression using the positive exponent. That means the result or answer should not have any negative exponent. The expression is 7 raised to negative 9. So we have a negative exponent here. To make the exponent positive, let's recall the definition of negative exponents and apply it. If you can still remember, we have the equation x raised to negative n equals 1 over x raised to the n. After applying that, we got the answer, which is 1 over 7 raised to the 9th power. The next expression is negative x raised to negative 5. We will also apply the definition of negative exponents in solving this. Doing so gives us 1 over negative x raised to the 5th power. Thus, negative x raised to negative 5 is 1 over negative x raised to the 5th power. Take note, we only changed the sign of the exponent but not the sign of the base. Remember, if a number has a negative exponent, just get the reciprocal of that number and raise it to the reverse of the exponent, which is positive. Now let's solve the other way around. This time, we will write the expression using the negative exponent. So the expression is 1 over m raised to the 6th power. If we're going to look back at the definition of negative exponents, there is one more equation representing it. That is 1 over x raised to the nth power is equal to x raised to negative n. Applying that concept to the given expression, we will have m raised to negative 6. Therefore, 1 over m raised to the 6th power is equal to m raised to negative 6. Now let's try expressing it into a power with a negative exponent. The given number is 121. Because 121 has the same value as 11 squared, we can equate 121 to 11 squared. So the given number became a number with a positive exponent. In order to express it in a negative exponent, we need to apply the definition of negative exponents again. After that, we will get 1 over 11 raised to negative 2. Just remember to get the reciprocal of the number and the exponent will be the reverse. Now it's time to see if we understand what we have been discussing. Let's now apply everything we have learned so far. We will simplify each with an expression. Let's start with the product of 3 squared and 3 raised to negative 5. Since we have the same base, which is 3, we can apply the product of powers, wherein if x raised to m is multiplied by x raised to n, the answer will be x raised to the sum of m and n. In short, we will just add the exponents and then copy the common base when multiplying powers. So just add 2 and -5 and copy the base. 2 plus -5 is -3, so the expression will become 3 raised to -3. As you can see, we have a negative exponent. We can now apply the definition of negative exponents. Doing so will result to 1 over 3 cubed. 3 cubed is 27, so the product of 3 squared and 3 raised to -5 is also equal to 1 over 27. Next we have z raised to the -10 over z raised to the -8. Notice that we have the same base again, so we can apply the quotient of powers here. In applying the quotient of powers, we just subtract the exponent of the denominator from the exponent of the numerator. Following that, we will just copy z and subtract -8 from -10 for the exponent. Simplifying that will give us z raised to -2. Let's write it as a positive exponent. To do that, we will just apply the definition of negative exponents. And that's it. We got the answer, which is 1 over z squared. We're done with zero and negative exponents, so now let's move on to the last topic, which is writing decimals using the power of 10. To understand it faster, we'll just look at some examples right away. We have 0.0001. The first thing we need to do is write the decimal form as a fraction. Our given is easy to write in fraction form. The place value is 1 of 10,000th, so the fraction form of 0.0001 is 1 over 10,000. That doesn't have an exponent yet, so let's express it in a power. Because 10 raised to the 4th power is the same as 10,000, then we can express it as 1 over 10 raised to the 4th power. Now it's just time to apply the definition of the negative exponent. How do we apply that again? Just get the reciprocal of the number and the exponent will be reversed. Thus, 0.0001 is equal to 10 raised to -4. Let's try solving something a bit more complicated. In this example, we will find the missing exponent. Look at our given. What should be the exponent of the numerator if it is divided by d raised to -1 and the quotient is d raised to the 5th power? There's an unknown number here, so we should represent it by a variable. Let x be the missing exponent. So, our equation is now d raised to x over d raised to -1 is equal to d raised to the 5th power. Like what we did in one of the previous examples, we will apply the quotient of powers in this example, since we have the same base. Exponent of the numerator minus exponent of the denominator. Don't interchange that because you will get a wrong answer. So the exponent of the term on the left side of the equation is now x minus -1. To solve for the missing exponent, we will bring down the exponents of the bases and we will have an equation which is x minus -1 is equal to 5. To simplify this, we have x plus 1 equals 5. To solve for x, we need to isolate it on the left side of the equation. To do that, just subtract 1 from both sides of the equation. 1 minus 1 is 0, and 5 minus 1 is 4. Thus, x is equal to 4. So the missing exponent is 4. That's all for now. Numbers with zero and negative exponents are fun and easy to solve. Keep solving more examples if you wish to master it. I hope you had fun while learning. Thank you for listening, and we'll see you next time.